What's going on YouTube? This is Ipsec and we're doing Checker from HackTheBox, which is a pretty unique box that has a lot of cool techniques. It starts off with two websites running some open source code. The first is Bookstack and the second is Teampass. You can enumerate the version of them and discover an authenticated server-side request forgery in Bookstack and unauthenticated SQL injection in Teampass. Obviously, we start with the SQL injection, and that will get us credentials over to the Bookstack application, and then we can exploit the server-side request forgery vulnerability. However, we're not going to just use it to make a web request. We're going to use a pretty cool PHP gadget that allows us to turn a SSRF into a file disclosure vulnerability, which leads us to an SSH session as the reader user. And this user can run custom binary with sudo, and upon reversing it, we discover it writes a string to shared memory and later uses the string in a popen call, which is vulnerable to command injection. So we create a program to monitor the shared memory space, and once the string is written, we update it with the payload to exploit the command injection vulnerability. It sounds pretty tough, but once you do it once, it becomes much easier, so let's just jump in and do it. As always, we're going to start off with an nmap, so -sc for default scripts, sv, enumerate versions, -vv for double verbose. This gives us things like the TTL, OA, output all formats, put in the nmap directory and call it checker, then the IP address of 10.10.11.56. This can take some time to run, so I've already ran it. Looking at the results, we see 3 ports open. The first one being SSH on port 22, and the banner tells us it's an Ubuntu server. We also have HTTP on port 80. Its banner tells us it's Apache, and we also have HTTP listing on 8080, which is Apache as well. The interesting thing is, on the title of both these pages is a 403 forbidden message. We also have this warning up at the top of nmap of something happening. I don't know exactly what's going on here, but let's go take a look at the website, because right now we just see 2 forbiddens. So let's see if we're actually forbidden. So we'll do HTTP 10.10.11.56, and it redirects us over to checker.htb. So nmap didn't tell us about the redirect, which is a little bit odd. So let's go ahead and curl it. So we'll do a curl 10.10.11.56. And we get the page. So what this tells me is there's probably some type of web application firewall configured with Apache, most likely going to be mod security, and it's blocking on the user agent or something like that, right? We could add like -- user agent, and then let's try nmap. It still works. Is it like nmap scripting engine? There we go. We get blocked. So yeah, there is a blacklist on the user agent nmap. There's probably a bunch of other things that it's blocking, probably also going to block like go busting and things like that, like just fuzzing against the web server. So I'm not going to run a lot of automated tools against this just in case mod security is in play. We could try to enumerate that, but let's just go take a look at the website first. So let's do a sudo v etc host to add the checker.htb to my host file. So 10.10.11.56 checker.htb. This will let us hit the page. And if we go here, we get a page called Bookstack. If we try going to port 8080, so I'll do 10.10.11.56, 8080, we get a page called Teampass. So let's go ahead and look at Bookstack. If we look at the page source, we can see in the style sheet, it has version is equal to 23.10.2. And this could be the version of Bookstack it's running. It could just be a bunch of other things, right? So I always like just looking at it to see if it makes sense as a version for the software. So if I Google Bookstack, what is that version? 23.10.2. So 23.10.2. I'm going to add release to it. And let's see. We have vulnerabilities, but we do have Bookstack version 23.10. So it does look like that is going to be the version. If I go to like cvedetails, we can look at all the vulnerabilities for it. There was a server-side request forgery, but that isn't really that interesting to me. We can have the web application make a request, but we don't know exactly what that buys us yet, right? So just keep that thought in the back of the mind. But we can look at the vulnerabilities for Bookstack, and let's see. We are 23.10, so that's 22. So probably one of these top 2, right? So the first one is allows attackers to confirm existing system and users. So this is like user enumeration. I don't think that's going to be too important. This is going to be that SSRF I think we saw, allows for filtering local files on the server because the application is vulnerable to server-side request forgery. So we have something here that's going to let us have a file disclosure according to the CVE. But if we look at it, it will require some type of privilege. We don't have any account yet. So let's go ahead and look at Teampass because we don't have anything to go off of here. We need an account in order to perform that SSRF. So looking at Teampass, I don't see any clear indication of a version just like we did on Bookstack in the source code. So I always go to GitHub and then go to their page and see if I can find a file that discloses the server version pretty easily, right? A lot of times you may be able to access like the README, the changelog, things like that. So going over here, let's see. The first thing I can get is security.md because that file just stood out to me. Security.md, not found. So we don't have a direct clone on this, so we won't be able to just get anything we want. We could try readme.md lowercase. See if this exists. And it does. So we have the README, but looking at it, the README was updated last year, so it's not updated that frequently. Many of these months, days, etc. But we could potentially identify around the time based upon the README. Let's just see if there's any other files, right? The composer.json is always a good one, or the lock, because that contains all the libraries the application uses, so it gets updated pretty frequently, right? But we have forbidden on both of those. So we can't access these files. There is a changelog.txt, so let's go ahead and grab that. So I can do changelog.txt, and this isn't what I was expecting, honestly. Like I'm used to seeing like versions, things like that in the changelog, but we just get an HTML page. But looking at it, the thing that really sticks out is a copyright. We have 2022. So let's go ahead and take a look at the history of this changelog because we see the last commit was updating the year to see how often this updates. So if we go over to history, let's see, update of the year. I'm going to go and look at this commit, and then we'll look at this one and the one before. So here, they're changing quite a few things, honestly. Looks like the year on, a lot of things. So this commit, they updated the year on pretty much everything. So we know they updated at the start of 2023, which is good. And this one, let's see, adding API. So they're changing from Teampass API to Teampass and have API as the version. Let's see. So that is, let's see. Can I just go copy? Can we look at the file? It's taking its sweet time to pull. Project Teampass. So we're probably just before this changelog. But the key thing is the copyright is correct. So it is going to be a version from 2022. So we can do kind of the same thing we did before with the CVE. And let's just search Teampass here and look for possible vulnerabilities. So if we do Teampass, let's go over here, get over to the product, vulnerabilities, and let's see. Doesn't check mail. Is there a way to like filter authenticated? Maybe not. Let's see. XSS, sensitive, escape. Here's a high CVE. This is code injection, so we can take a look at this one. More cross-site scripting, escaping. Let's see. There are a lot of CVEs related to this. I do see a SQL injection as well. So looking at this one, looking at the privileges acquired, this is high. So we don't have any credentials yet, so I'm going to go ahead and ignore that. Looking at the SQL injection, privileges none. So this is unauthenticated SQL injection, which is nice. We can look at the patch that fixed it. I'm not going to spend too much time here, but this is just talking about the endpoint and they're doing some sanitization, it looks like. But if we go to this blog post, it talks about the exploit, right? The authorized endpoint is vulnerable to SQL injection, and they normally just shove a hash in here to bypass login, but it doesn't contain a valid username when you do that, and the data gets put under the JWT public key. But instead of just reading through this, let's just run it and step through each step to see exactly how this works. I find that to be a pretty good way to analyze things, right? So I'm going to just copy this exploit here. We can get an idea of what it does. We should always do a cursory look to make sure it's not like doing anything dangerous. We set the URL. We're just hitting this endpoint to see if the authorize is enabled, or the API is enabled. If it is, then we can potentially exploit it. Right here, they just make a arbitrary hash because they use that for the SQL injection. So let's see. They have a token, and then they're just curling it. Okay. So let's try this. Let's just run it. And actually, before we run it, let's set a proxy. We'll run it and then set a proxy. That sounds good. We'll do exploit HTTP 10.10.11.56.80.80. And then I think it adds everything else for me. It finds 2 users and then gets me admin and Bob. So let's go ahead and add a proxy to this. So where it has curl, I'm going to do -x, and then I think it's lowercase x. I hope it's lowercase x, 127.0.0.1.80.80, and maybe an uppercase x. We'll see. Okay, let's just comment this out without the proxy so we can easily revert it if we want to. There we go. Run this. Let's make sure our proxy is on. Sweet. We had that correct. And I'm just going to turn intercept off and we'll look at it from the history tab because this lets us see what it does, right? So first we do a git. We get a 422, which I guess it's happy with. Maybe it's just looking for if it's not a 404 error message. And here's the first thing. So we're doing this SQL injection here. We see union select ID, and then I think we're just hand jamming this hash in. And then here's where the SQL injection comes from, right? Select star from Teampass user where password is null. Oh, it's doing a count. So we're looking for how many users exist when there is a password set, right? If we look at the response, it's not that obvious what's going on here, right? But if I double click this and then look at it from Burp Suite, it is obvious, right? We have JSON data. So let's just make this in Bash so it's a bit easier to read. We'll do echo this base64-d jq dot. And there we go. So for the username, it's our SQL injection because that's what we tried to log in as. And then it's putting the data actually in the private key, or the public key of what we're extracting, right? So the query, we're looking for how many users exist, right? How many users where there's a password set, and we get 2. So let's look at the next query. So we can just go ahead, do the same thing we did, copy this, and then echo base64-d jq dot. So right here, what we're doing is selecting the login from Teampass users where password is not null, and we're grabbing the very first user, which is admin. And this number is going to increment because it's going to be the very first one, then it's going to be 1 for the next one. And if there were 3 users, the next thing would be 2. This is how many lines to return. So we get admin. So the next query is probably going to be grabbing the password hash, right? So let's try this again. Delete that, paste that, go, query, and where the public key is, we get the password hash of admin. So that's how this SQL injection is working, which is pretty neat. I haven't actually seen an SQL injection like return data this way. It's really cool seeing it in the token, I think. It's just something I've never seen before, but let's go ahead and try to crack these. So I'm going to go over to the Kraken, which is just another box where I have Hashcat installed. So we can do v hashes, and I'll call this checker dot, I guess, bcrypt. And we'll do username colon the hash. And let's do /hashcat. The hashes, so we'll do hashes checker bcrypt and then opt word list rocku. It's probably going to tell me this mode conflicts with other ones and make me specify bcrypt, which I think is 3200. And that's if I put these in the correct order. The word list comes first and then the hash file. Oh, wait. I need the username. So let's do -- username. I think that is, because my format is user : password. So that's what it is. So let's see, we need the mode. So we'll do mode 3200, and then it's going to start cracking, and we'll see if it gets any hits. It's initializing it right now. It should take just a couple seconds. And the reason why I like having the username part of the hash is because after this, you can just do hashcat show, and then it'll tell you where this password went to, right? So we see one user cracked as cheerleader. It's not telling us. We could grep this and find out ourselves, or we could just do a -- show command, right? So if we get rid of the word list, -- show, we see Bob, the hash, and cheerleader. So let's try to log into the app with the password, right? So we can go back over to Teampass and then log in with what? Bob and cheerleader as the password. In progress, and it lets us log in. Awesome. And let's see. We have Bob access and SSH. So let's go over to SSH. We can see this. We have Bob's password right there. Let's just copy it. And I'm going to do vcreds.txt Bob, but that's not what I copied. That is SSH Bob at checker.htb. Paste in the password. Did I not copy it right? Hiccup. Oh, the account is reader, not Bob. So reader. Paste in the password. And it wants a verification code. So this is going to be multi-factor authentication on SSH. Most likely probably going to be Google Authenticator, but we'll probably enumerate that in a little bit. But we can't just log in with SSH. Let me update the creds real quick because that's not Bob, that's reader. So if we think back, when we were enumerating Bookstack, we had a ability to retrieve files off of the local server, so a file disclosure vulnerability. So we can potentially steal the two-factor seed with this file disclosure and then let us log into the application. So let's look at what the other password was. It's loading right now. It's not the quickest. We got a Bookstack login. Bob at checker.htb and my secret wiki password. So if we go here, we can do Bob at checker.htb, put in this password, and we get logged in. And there's some pages here we can take a look at. So we have this like basic backup with CP. So recursive copy, update, whatever. This is going to become key later on. They like backing up the home directory to backup home backup. So we'll just keep that in the back of the mind. This is Linux basics. But we want to look at the way to retrieve files off of Bookstack. So if we go back to this CVE, let's see. I think this one is just like the changelog, so that's not going to be too interesting. They have the POC here, and then a video of showing them exploiting it. I'm not going to watch the video because it's just slow to do, but we can explain what's going on. They put the URL inside this image, and this is going to be a really cool attack that I can't fully explain, but we're going to demo it because most people would just think this is a way to make server-side request forgery attack work. But in PHP, apparently you can convert a server-side request forgery often to local file disclosure, which is pretty cool. So if we just base64 decode this, it's just going to be the URL, right? So all they're doing is putting this payload in the save request of a book. So let's just go create a book. So we'll do books, create new book. We'll do IPsec description. That does not matter. Save book. Create new page. And this is where they do the exploit. And if we watch the video, it would be clear. I never found a good blog post to show that had it in text form. So that's why I'm doing it this way. So we should be in Burp Suite now. Let's go over to proxy, intercept on. Let's go ahead and save the draft. So now we have the draft here. So what the exploit is having us do is, where is it? Right here. We'll copy this, go back in Burp Suite, paste it. So we put a URL here. This is just going to be having the server reach out to us. So let's create a URL. So we'll do echo -n. And the -n's important so you don't have the line break at the end. So we'll do 10.10.14.8, port 8000. We'll do /SSRF, I guess, and then base 64. If there's equal signs on it, you can cut them off. Or if you want to do the equals, I think you have to URL encode them. But thankfully, there's no equals right here. So I'm just going to put this URL in. We're going to hit send. It doesn't give us a response because it is making a request to us. Once we kill this, then that's when the request comes. And it doesn't give us any data here, right? If I made a actual directory, www v SSRF, please subscribe. And then we'll do Python 3 HTTP server, rerun it. So it got it. Look back here. It never puts the data. If we look at the draft, the please subscribe text isn't there either. Let's see if we can show that real quick. I think I put an exclamation point on it, but we're modifying the HTML, which is down here, and we just have a dead link, right? So it never actually puts it here. So that's why we can't just include a file easily. But what we can do, I think, let's verify this real quick. I may be wrong with what I just said. So let's see. Locate star.png. Find /dev null grep png. Okay. I'm just going to copy this to SSRF, and we're going to test it real quick. So start it. Is it going to download the image? No, it's still a dead link. Awesome. So there's no way for us to actually see the data, but we can do a error-based brute force and brute force it one character at a time because of a weird PHP quirk. So let's go into that. I'm going to Google let's see, PHP Filter Error Oracle. I think this is going to be it. It's a blog post on Synactive, and it's going to be relatively tough to understand, and I'll do my best to explain this. This article pretty much starts off by saying PHP filter chains are the gift that keeps on giving for PHP hackers, which is definitely true because people keep finding new ways to abuse filter chains in order to increase the severity of their vulnerability. The PHP filter chain itself is not a vulnerability. It's just something that gives a lot of control over to the user that they can do a lot of weird things with, right? Back when I first got started in HackTheBox, I think it was 2015, 2016 timeframe, the only known thing you could really do was convert files to base 64 with the filter chain. And this was used in include statements so you could leak source code, right? Because if you just include a PHP file, the include will execute it and you don't get the source out of it. But if you base 64 encode it, now you get the source code, and then you can find sensitive things like passwords and things like that in PHP scripts. People eventually found out ways to write data with PHP filter chains. I think this was probably like 2022 timeframe, but that allowed you to take an include statement, and even if there wasn't a file on the server, you could do a PHP filter, create that file out of thin air with whatever PHP gadget you wanted to get code execution. It's a really cool attack path that still works today. People eventually found out you could also just use this to write magic bytes to beat MIME type checks. In the Big Bang video, which we did a couple weeks ago, I think it was, we used filter chains in order to exploit a buffer overflow that turned a file read and PHP into a file write. That was a really cool attack. I definitely recommend watching the Big Bang video. But here we're going to take a server-side request forgery and turn it into a file disclosure. So let's go down a little bit. And it starts off talking about where they found this. This was in the Down Under CTF of 2022. And this was the application, right? It's just a Docker, basic PHP config, and copying index, copying the flag, and here's the code. This only opens the file and reads it. It doesn't print anything back to the user. So there's no way to just say, hey, give me /flag. You have to abuse something in order to get it, because it's not like a file get contents that's going to echo the contents of the file back to you. It just reads it, does nothing with it. And then relatively good meme. PHP really loves file leaks because you can do so much from them. But let's go into the attack, right? It's going to start off by making a file to be the maximum size. And it does that by doing a bunch of conversions. So it's going to convert to UTF, then Unicode, UTF, USC4, and does these encodes over and over again until it hits the maximum memory limit for PHP, which I think is 128 megabytes, right? So we just do this encode. This is kind of an example of it. If we just do I convert UTF-8, UCS4 little endian string, this is what it looks like. Then we're going to add another one. We add more bytes. So we just keep doing this to make a huge file. And eventually we exhaust PHP and that crashes. So whenever it crashes, you can potentially turn that into like an error-based Oracle. And they're going to use dchunk to do this. And they don't give a lot of information on exactly what dchunk is. Even in PHP documentation, it's kind of slim. But essentially what they found out is if you dechunk something and it begins with a hexadecimal character, it just erases that. So if we have a payload, we convert it to be the maximum size of 128 megabytes, and then we send it, it crashes. If we do a dechunk and it still crashes, we know the first character wasn't hexadecimal. If we dechunk it and it doesn't crash, now we know that very first character was hexadecimal, right? And then they can do other weird things with iConvert to change that character around, like rot13, things like that, in order to figure out what hexadecimal character that was, right? And then they're also going to do another thing in this, which will just reorder the byte. So eventually they change like the start of the string here. They do iConvert. Now the start of the string is T and this is at the end. So they kind of just change the order so they can now brute force the entire file. That's essentially how this all works. So I'd highly recommend reading this. I don't fully understand enough to explain it, but hopefully after we demo the attack, it'll kind of make sense to you. So let's go ahead and do that. Let's see, if we go to GitHub, we can download this exploit. So let's just do a git clone. And then let's go into the directory. And let's see. There's going to be one thing we have to do. We have to update a file in the actual GitHub. They talk about like you probably should use the class. I don't know exactly how to do it, so I'm going to do a relatively hacky thing and find where it makes the request and hand jam our modification in, right? Because this isn't expecting us to have to put this in, right? The whole like base64 image thing. So that is going to be in this, in core, and I think it's like requester.py. I'm going to see where it makes the request. So here it's making the request. And we just want to update our filter chain. So instead of just being the PHP filter, we also have our URL encoded payload, right? So it's an HTML image. So we'll do this. And then we need to do a base64 encode on the filter chain. And it wants that as binary, but we want it as ASCII, like that. And then we terminate it with a single quote slash and caret like that. There we go. And then we have to import base64. So from base64, import b64 encode. And I don't know why it just did 2 4s there. Save that. And then before we actually run this exploit, right? What is it? Filter exploit.py. Make sure it works. I want to make sure we don't have to send the data as JSON. It looks like it does support it, but it would be slightly easier if we just did this all as the standard xwww URL form encoded. So let's see if we can change that real quick. So we'll do this, www form URL encoded. And then let's change this to be just HTML is equal to our payload. So this just simplifies the arguments for us if this works. 8,000, run it, and it looks like it does. Awesome. So if we go back to the help, what we need to do, let's do Python 3. What is it? Exploit, filter, exploit like that. Let's see. We can set the target. So we'll do -- target is equal to HTTP checker.htb. And then we need the page. This. Paste that. And then let's see, what do we need? The verb, this is going to be a put request. We have that here. Let's see, what else? The parameter that we're using. So that would be parameter HTML. And then let's see, we need the headers. So this is going to be cookie. And then let's grab this. So I'm going to add this header. And then we also need the cross-site scripting protection, XC surf token. And then that's going to be this. Okay, headers are set. I'm going to do -- proxy HTTP 127.0.0.1 This lets us actually see what's going on. And let's see. Is there anything else we need? I feel like I'm forgetting something. Oh, the file. Duh. So let's do etc hostname because that's a relatively small file and we have an idea what it's going to be. Let's see if this works. It's taking its time. If I go over into the proxy, oh, there we go. We can see a bunch of 500s and then some 200s. So this is it brute forcing the characters one character at a time, right? If we look at what the payload looks like, let's see right here. Let's just do a echo -n base64-d. That's not what I expected. Oh, because I got random HTML stuff too. That's probably it. You can see the filter doing just various conversions. There's a ROT13, D chunk, more conversions. So it's working. It's just slow. And you see it does a bunch of 500 requests because that's it failing. And then also a lot of times when people are using these PHP filters to do things, it loses like the last byte of the file. And if you prepend a lot of data to the file, it loses more than 1 byte. So you don't always get the end of the file, which is a bit odd. But we can see that's probably right. The host name of the box is probably checker, right? So we could try and get the PAM configuration for SSH. I'm not going to let this run all the way because it's going to be really slow. But generally, if you're doing MFA on SSH, you have to modify this pluggable authentication module to put the program, right? So we can try to include this, and then we'll let it go for a few characters. There we go. See, it's starting to work. Let's see. While that goes, let's go cat creds SSH reader at checker.htb. I will paste this in. And then we can also just Google like this string. So I'm going to say SSH, put verification code in quotes like that. And Google Authenticator comes up quite a bit, right? So chances are it's using Google Authenticator. Let's see, Google Authenticator, let's do setup. Let's see, SSH MFA Ubuntu. Is that going to be a better one? Let's see, is this going to use Google Authenticator? Yes, it does. So configure SSH. This is them editing the SSH config. They're adding this line and the PAM that we said. So that's how we know they'd run it. And then configuring. Let's see. I think this is the file. So I think that file goes into your home directory. So I'm going to kill this because we've accepted this is working. We can change the file to be home reader Google Authenticator and see what happens. And it errors right away, which makes sense because we can't go into the reader directory. But if you remember, back when we started on this box and logged in, they talked about backing up the home directory. And they did the home backup and backup home backup, which is a bit odd. But let's try this. So file. Let's see, can I put this on like that so it's easier to see? And let's see if we can read this file. It looks like we can. We got the first character. So DV, and keep in mind it is it extracts it over base 64, so then does the decode here for us. But we're getting the Google Authenticator time-based one-time pad key. So I'm going to pause the video and let this finish. Okay, now that we have this file, let's go ahead and try logging in again. So I'm going to get the credential for reader again. And we can SSH reader at checker.htb. Paste this in. And then I'm going to run OAuth. Is it like this? There we go. OAuth tool, TOTP, specify this. Hex encoding failed. There's an option for that. Base 32. Whoops, need a space. There we go. So let's try 667943. And we get a weird error. And I don't know exactly why it's doing this. Well, it's doing it because the time is wrong. But if I just put like 121212, we get back to password. So it fails differently when the time is close or something. I don't fully understand that. It should either be failed or success, but it looks like there's 3 cases. And we can get the server time through curl, right? If we just look at the headers of checker.htb, we can see there is a date header, right? So we can grep for date. Let's do a -s for silent. There we go. And then we want to grab everything after the delimiter of a space. Everything after 3. Like that. Is that it? There we go. So we have the date format here. And then we can use the date command of date-d to format this how OAuth tool wants. Forget exactly how that is. That's going to fail. Python 3, not OAuth tool, like that. Let's see the date. There we go. So we do date like this, and then plus %y for year, lowercase m, lowercase d, hour, minute, second, like that. Oh, that's not working. Put this in quotes maybe. There we go. So now we have the date. So we can go back to the OAuth command and use this. Where is that? Right here. And then we can do -- now is equal to, and paste this in. Hopefully that works. I just probably did quoteception with all these double quotes. Looks good to me. We got to get the password again. I should probably use like SSH pass or something so we don't have to keep copy and pasting, but oh well. Run this. Let's get a new code. 708017. And there we go. We get logged in. Awesome. So the first thing I like doing whenever I SSH into a box, especially if I know the user's password, is checking sudo rules. And we can see I can execute this bash script as root. So let's see exactly what the script is. So I'm going to cat it. And then we see the very first thing it's going to do is source the current directory name, which is going to be the opt hash checker, and then .env. So let's see if we can read that environment variable. So if we cat.env, we can't, we get a permission denied. We look at the permissions and only root can read this file. So we never get access to this. The next thing it's going to do is, I guess, check if this is, I don't know exactly what this is doing. It looks like it's just grabbing the username, but making it like overcomplicated. So let's do echo, we'll do it all caps. That works. If I do ip0, that says all numeric, so probably alphanumeric. Oh, maybe that's getting rid of special characters. Yeah, that's what that's doing. So that's going to get rid of special characters. And then we're going to run this binary, this check leak. And if we look at it, we don't have execute permissions, only root does. So we have to execute this with sudo. So let's do a sudo and execute the script. So if we do sudo this, we'll check reader, right? And we see user is not found in the database. I'm going to do Bob because that was the user of the Bookstack application. So I know it's a user on the box. And we see it says password is leaked using shared memory at this as temp location. User will be notified. So if we do a ls, we can also see there are leaked hashes. So I'm guessing Bob's hash is in this file, right? But let's go ahead and copy this binary over to a box so we can begin analyzing it and see what the vulnerability here is. So we're going to do an nc lvnp check leak, and then we'll do port 9001 and direct to a file like that. There we go. We can cat check leak, and that'll be to dev tcp 10.10.14.8 9001. Okay, so now we have the file on a box. I'm going to open up Ghidra, and then we'll just analyze it and see what we have. We probably should have done a file against it to see what type of binary it is, but we'll just YOLO for now. So let's go here. Project name doesn't matter because I'm not saving anything. Open the little dragon, and then we'll go and select this binary when it comes up. So let's do checker, and then we'll do check leak. There we go. Analyze now. Analyze. Okay. And I'm waiting for this to finish and us to have like a main function. There it is. we have main. So let's take a look at kind of what it's doing. So right off the bat, we're going to get environment variables, DB host, user, password, name. So this is going to be all the like environment stuff we had saw. And I'm just going to quickly rename these. So if they show up later, we know exactly what it is. This is DB password, and then this will be DB name. There we go. DB host, DB name. Okay. So the first thing we're doing is, I don't know what that's doing. Right here, let's see. So this is failing to load environment. So if we don't get any database credentials or something, this is just checking if any of these variables is equal to 0. Then down here, let's see. This is probably incorrect number of parameters based upon the usage. And then let's see, username's too long. So if we have a username that's longer than 20 characters, it's going to error. And here's the first thing. Fetch hash from DB. DB host, DB user, DB name, and this. So this is going to be arg user, I guess we can call that. And that'll be a pointer. This will be maybe handle DB maybe. I don't know exactly what this is. But if we look at fetch hash from DB, we could name these things. The last thing we got was user. So this is going to be username. The rest I think was like all the environment variables. So it's not going to matter too much. But we see we're using the MySQL library to run a query most likely. We're doing real connect. So there's all the DB strings. And then we have select password from Teampass users where login is equal to the username. And then we do the MySQL query. And this just gets the hash. So nothing too fancy there. It is using the MySQL library, which is going to be something to keep in memory when we go later on in this program. So here we have the hash from the database. Then we're going to do this check bcrypt in file. So all we're doing here, and this is going to be hash, right? PW hash. There we go. Because we're comparing the PW hash against the leaked hashes, right? And if that string does not exist in that file, it's going to say the user is safe. Else, the hash existed in that file. It's going to say password is leaked. And then I don't know what this is doing. It's checking if something is not set, I guess. We're going to flush standard out. And then we're going to write to SHM. And this is interesting. This is going to be write to shared memory. And if we look at this, I'm guessing all this stuff is probably because it's like compiled, maybe debug or something. This is probably going to be stuff to help a debugger. I don't know exactly what that's doing here. But we see it's doing this SHM get. So this is getting shared memory. And you can think of this as like dev SHM. It's just a spot on the box where memory can be shared between various programs. And beforehand, we're going to do a time. Then we're going to call srand. Then we're calling rand. So we're getting a random number based upon the current time. And then we're going to, forget what the percent means. We're limiting the file size here. It's a modulo operator, I think. So this is just going to limit how big it is. If the number goes beyond this, then it kind of rotates the beginning and goes to 1, right? So this is just limiting the size that the key can be. This will be the number of bytes. And then this is actually the file permission. I was wondering if the tooltip would tell me. Maybe it does right there. And SHM flag. So yeah, this is going to be the permission. And 0x3b6, this is in hex format. If we go over to Google, we can probably convert 0x3b6 to octal. And this is going to be the format you're used to seeing. It's going to be 1666, right? I think that's the sticky bit is set. That's not too important, but the important thing is the permission is 666, which means anyone can read and write this memory space. So we have read-write access to this even if we're not part of the program. So right here, we're checking if it's -1. So this is going to mean that it could not allocate this memory for whatever reason. Right here, we're going to, I want to say read the memory right here with shmat. What is that doing? Let's just Google exactly what this is doing. Does this read and see? Oh, it attaches to the memory space. So we see if we can access it, then we attach to it. And then we're probably going to write to it somewhere. shmat, there's time, store, there, that's detach. So right here, this is going to be, I'm going to call this shmid. So we got there. What is this string? shmid. So it highlights the next one. Right here. With this printf, we are writing leaked hash detected at, and then the probably memory location. And then we're putting this caret, and then is that the hash exactly? I think that's the hash. Let's see. If we go back here, let's do the sudo command again. Password is leaked. User sharing. So it never actually prints that. But I think this is going to be the hash. We'd have to like go back here, C time put. Let's see. What are we doing? This right. I'm pretty sure that's going to be the hash. So we're writing to a place in shared memory that anyone can access. So what are we going to do after that? We write to shared memory. Then we print that string. Then we're going to sleep for 1 second and then notify user. And uvar2, this is going to be the shared memory location or ID. So I'm just going to rename that to shmid. We go to notify user. I'm just going to label that because that's important. I think all these, again, are database things. So let's go down here. We're going to get the memory location. So it's important to note in that main function, when we call this, the notify user, we're not passing the password hash or any of that in, right? We're just writing to a shared location and then saying, hey, that's where it is. Go and grab it. So we have this. Let's see. What are these strings doing? shmid, we can just label this. There we go. Call it handle shared memory. I don't know exactly what to call it. If we can't access it, it's going to error out. This haystack is probably going to be the data. Let's see. SHM, this is allocated stuff. Unable to attach. There we go. So this is going to be a string. So right here, let's see. I don't know what this is exactly doing. So no hash detected in shared memory. So this is, if we get down to this function and the hash is blank, it's going to say nothing, right? So then we're going to go here. So we have data in the shared memory. And we're going to look for the character of that greater than sign. And then we're going to get to that location. So right here, this is going to be, can I do this in a name? Let's see, output spot. That's a horrible name. I don't know. I don't know what to call this, but this is going to be the string of the location of this. Maybe location of that. There we go. So we're going to find the location of the greater than sign. And what we're doing here is sending that to this trim bcrypt hash. and then +1, right? Because when we looked at what it was before, it was like leaked. Oh, right here, I think, right? It was right here, or like leaked hash at loc, and then we passed in a variable, right? This is the hash we pass in. So all that's doing is finding where this is in the string, adding 1 so we get rid of the space, so we just have the password hash. So that's where that is. And this is going to be PW hash. And here we're going to make sure we have a MySQL password set. This is making sure that set env succeeded. And right here, we're going to probably get the length of this command, because we see we're changing that. So this is going to be like a length indicator, maybe. I don't know exactly what to call it, but we're reusing that variable. So I renamed it. It's just going to be like length of string multiple times, because we're going to allocate this length in memory. And then we're going to put this string there. And this is going to be MySQL. This is going to be the user, the database, email, Teampass user, and then password hash. So this is why this function needs the password hash. We're just going to do a MySQL and find the user that has this password hash, right? And then what we're going to do with that is, let's see, a popen. So if you're still following me, this password hash comes from shared memory. And we're going to do a popen on that, and that's part of a MySQL string. So the challenge here is when we go into main, we check, we validate that a user has a leaked password. Then we're going to sleep for 1 second. And in this second, we're going to write to the same shared memory location, replace that string with one of our own, and that's going to have command injection, because popen is vulnerable to command injection, right? So all we have to do is escape this single quote in the MySQL, and then we can do a semicolon and then a command. But it's going to be a little bit tricky to do. So let's try it out real quick. We'll call this SHM write, I guess. I don't know what to call it. And then we're going to do the standard includes in C. I probably should do this in like something where I have Copilot, but I've never used Copilot with C. I don't know how it would do and how confused I'd get. So we're just going to do this manually and hope that everything works. So let's do include, the last one. I think this is what we need. And then we can do int main. Okay. So what we have to do is first replicate the random thing, right? The shared memory location. And that was in the write function, right? So this is where they do the time. So all they're doing is an insecure randomization. They're just getting the current timestamp and then setting the seed to that and then calling random. So as long as we set the seed exactly like this program does, then all the random will be able to replicate. So every single second, we're going to just generate a number, check if that exists in memory, and then if it does, we're going to overwrite it, right? That's going to be the gist of it. So I'm going to do a infinite loop first. And then we're going to set the time. So now is going to be unsigned int time, and then we're going to pass in null. And then we'll call srand on now. And then the key, that is an integer. And we're going to do rand, and then the modulo operator. And I want to say that was 6 Fs, right? Let's count that. You don't see it here because they're doing it on the SHM get. That is 1, 2, 3. Is that 5? 1, 2, 3, 4, 5. 5 Fs. So get rid of that. 1, 2, 3, 4, 5. Awesome. So now we have the key set. So what we want to do is try to access this. So we'll do int shmid, and that's going to be the shmget that we've seen. We'll do key. I want to say it did 400 bytes. And we're going to pass in a 0. We're not going to do any permissions here. All we're doing is seeing if this place in memory exists. And if it does, or if that shared memory does not exist, this is going to return -1 if it fails. We're just going to call sleep, and this is microseconds. Let's see. Usleep. I will do half second. And I'm actually going to make this even quicker. So this is half a second. We're going to do this 10 times every second. And then we'll just call continue. So we get back into this loop. Okay. And then here, we're going to say key exist. So what that continue is going to do is it's going to go back to the beginning of the loop. So if we can't access that spot in memory, go back to the beginning. And now if we can, then let's do a printf just to let us know. Found key. And we'll print this out. And this is mainly a debugging thing because when I run this program, I'm going to get no output. So if I ever see this not equal to -1, I want to know because that means I'm starting to do something. If I run the program and I never see this print statement, then I know I have an error up above. So this printf, mainly debug. So now we have to do the shmget again, because we're going to access this the same way it did, which I think was, what was the permission bit it did? 0x3b6, 0x3b6, like that. There we go. And let's see. We have to call that what is it? Allocation. And we do shmid, give it a pointer. There we go. I think that's how we do the allocation. And now we just have to put the string in. So they used printf like this, point it to the shared memory location, 400 bytes. And what did they put in here? Leaked hash. So we'll do leaked hash, and then it doesn't matter what we have here as long as we have that. So right here it's going to get chopped off, and this is what's going to think the new password hash is, right? So we're going to do a single quote to terminate the parameterization in the MySQL command. So that's going to get us where we can do the semicolon, and then we can just do, let's do touch temp, please subscribe. And then we'll do another semicolon, and we'll do a comment as well. So it just breaks everything else off of that string. So I think that's good. And now we have to detach. So we'll do shmdt, and then handle that, and then let's break to exit the program. So I think we have this. Now, moment of truth, do I have typos? It compiles first time. So let's go ahead and copy this over. So I'm going to cat my program. Let's copy this. And we will go over here. And we probably need to SSH in again. Because we'll need 2 shells open to make this easy. We could just run it in the background, but I think it's better if we have 2 shells. So we'll do the OAuth tool again. cat creds SSH reader at checker.htb. Copy this. 174484. Sweet. I did that within the time. I was worried that would take too long. So let's go to cd temp v. I'll call it like exploit.c. Oh man. Nano. That's not the right clipboard. That is. Save it. GCC exploit.c. We'll call this exploit. And then if we run this, found key -1. That's not what we want. We screwed something really silly up. Shmget. Like, I'm confused real quick. Because we're doing if it does not equal -1 here. But we still got here. I am befuddled right now. We have something really silly that I don't know. Because we should just hit this. Oh. That's equal to -1. That's a stupid mistake. There we go. So that's why I did that print statement, because I knew I would make something silly. So now this program's running and it's just constantly checking the shared memory location. So as long as we did the whole randomization right, hopefully the program does something when we run this script. So I'm going to run it. We see found key 47. I kind of expected a error message. No hash detected in shared memory. So I think we screwed up the write. If I do LSLA on temp, we don't have that please subscribe. So we definitely screwed up the write. We found key. We do a git here. 3b6, so that's writing. I wonder if this needs to be longer. Let's copy this. I guess we can go try this. So let's write more data. Don't know what I just did. There we go. That's what I want. Leaked hash detected at something that. Save. Compile. Run. Let's do the sudo again. And it never detected it. There we go. Found key. An error. This looks better, right? So the MySQL errored out. If we do LSLA on temp, there we go. We have please subscribe. So I wonder if I just ran that multiple times if it would work, because it doesn't look like it just works every single time, but it's close enough. So now what we want to do is real code execution, right? Because we only touched a file here. So let's do cp bin bash over to temp. We'll call it ipsec, and then chmod 4755 to give it the set UID bit. Temp ipsec, like that. That should be fine. Save it. GCC and write. So now it's running. I'm going to run my script again. And it looks like it worked. We have found key, a MySQL error, failed to read the result, but if we do LSA on temp, we have IPSEC, it is in red. So this means it's going to be set UID. We can do temp IPSEC-P. And if we do ID, we are now effectively root. So if we do cd/root, we can get root.txt. So that's going to be the video. Hope you guys enjoyed it. Take care, and I will see you all next time.